Well, I'm Rob Malechka. I'm a chemistry professor at Michigan State University, currently the chair of the department. I'm also the co-founder of BoroPharm, a company that is based right now in Ann Arbor. The company is a company that uses green chemistry to make building blocks for organic synthesis, primarily being used by groups in the pharmaceutical industry, agrotech, increasingly in the OLED business as well. Yeah, BoroPharm was started basically out of technology that was developed in the research labs of my colleague Mitch Smith, an inorganic professor at Michigan State University, as well as myself. What we have is chemistry that enables us to make the building blocks without starting with halogenated aromatics, which have a lot of environmental baggage. We recognized that the chemistry was very useful to the pharmaceutical industry because the compounds we were making are key to many of the syntheses that you'll find in pharma. In fact, we were contacted by many of our colleagues in pharma who actually wanted some of the compounds that we were making because they're hard to make traditionally, and in many cases our chemistry made the impossible possible because of the nature of the chemistry. So we knew we had interest from pharma. We knew we had a green method, and we thought that combination would give us a business that was competitive in a globally competitive market. We actually thought we would get investors, and one investor in particular told us that he thought the company had a small chance of turning a profit right out of the box because of the technology. The problem was he doesn't want small profits, and we should take our mortgage papers and go to the bank and start it ourselves. And that's basically what we did to get started. We brought in a CEO because we recognized that being full-time professors and a full-time running a company is just not the way to go. We were fortunate to also receive funding in the form of a subcontract through the Michigan Economic Development Corp's 21st Century Jobs Fund, and that allowed us to get going. And today we're selling compounds. We are profitable. That person was right, and we're selling compounds all over the world. The relevance to pharma of the compounds we're making are called boronic esters, boronic acids, compounds derived thereof. They're key to a reaction called the Suzuki reaction. And today, if you look at drug discovery operations, about 40% of all carbon-carbon bonds are being formed via this sort of reaction, which uses the type of building blocks that we make. The other key to the relevance of pharma is that if you want new drugs, you'll need new compounds. New compounds probably are going to be built by new building blocks. And the regiochemical patterns, the substitution patterns that we can offer pharma through our chemistry, both in terms of the arenes as well as the heteroarenes, these are non-traditional in many cases and very difficult to source from outside suppliers that use traditional chemistry. So it's a combination of we're making the types of compounds they want, really unique compounds that give them a way to exploit their creativity, but also we're competitive because it's the green chemistry makes us competitive. What we're able to do is we're able to carve out a lot of steps that you would traditionally need if you were going to make the types of target molecules that we're being able to make. And traditionally you would be starting with halogenated aromatics. These halogenated aromatics can be themselves very difficult to make. But they also just carry a lot of environmental baggage. We just saw a presentation where they can be endocrine disruptors and things of that sort. So we're able to avoid those, which somebody has to make to start with, and then we're minimizing a lot of the steps on the way to our targets. Not only that, our only stoichiometric byproduct is hydrogen gas. We can also avoid all solvent in many cases. So when you don't have a lot of waste to deal with, when you don't have a lot of solvent to deal with, and because the nature of the chemistry is so inherently clean, we can telescope a series of steps together. And so there's no isolation, there's no purification in between synthetic steps. All this makes things economical, makes things efficient, and again allows us to compete against those all over the world who are using more traditional chemistry.